A rancher at Shady Acres can afford up to 300 feet of fencing to build a rectangular pen that must enclose an area of at least 2,600 square feet. What do you know already before we have even started any of the rest of this problem? Is this a system of equations? No, right? Not this time. Why is it not a system of equations? Well, if it's not a system of equations, what is it? Inequalities? How do you know it's inequalities? Up to 300 feet? At least 2,600 square feet? Yeah? You used your context clues, yes? Okay. That's a good English skill to have. Also a good math skill. Okay. For purposes here, let's let the length x be the larger of the two dimensions. Normally it doesn't matter, but we need to be specific here. Okay. Well, of course, unless they're equal. Determine which of the dimensions listed below satisfy the restrictions on the enclosure's necessary perimeter and area. Okay, so how do we find perimeter again? Add up all the sides. And how many sides are there for x and how many sides are there for y? 2 of each. So 2 times 81 plus 2 times 58. What you got? 278. Okay. Now he's not the only one doing this, right? You guys are all doing it? Okay. What about 2 times 111 plus 2 times 21? Very good. 264. What about 2 times 92 plus 2 times 58? 300 exactly? You sure? 302? Okay. What about 71 times 2 plus 39 times 2? 220. And then 120 times 2 plus 22.5, or sorry, 20.5 times 2. Thank you very much. So we just did all the perimeters at the same time because we had that set in our head. You okay with that? Okay, what about areas? Oh, okay, so 81 times 58. What you got? Okay, 4,698. What about 111 times 21? 2,331. Good. What about 92 times 58? I mean, 59. Sorry. 5,428. Okay. What about 71 times 39? 2,769. And then 120 times 20.5. Excellent. Okay. Now, what are the requirements again? So what is that? What is that? That's the perimeter, right? So can we look at that real quick? The perimeter can be up to 300 feet. What does that mean? Not over 300, right? Can it be 300? Yes. Okay. What about this? Does that work? Okay. Does this one work? Okay. Does this one work? No. What about this one? Yes and yes, right? Okay. So first of all, we can go ahead and fill this one in, right? Will it work? No. Sad. What about the area? What do we know about the area? Right? It even tells us area, right? At least 2,600 feet. Well, square feet, but you know what I mean, yes? Okay. So does this one work? Oh, wait. What do we know about 2,600? At least, so it has to be greater than, right? Okay. Do people get confused when that word is there? When they say least, they think, oh, it has to be less than. But you guys know better than that, yes? Good. Okay. So what about this? Does this one work? Yes. Okay. Does this one work? Oh, so sad. Does this one work? Oh, we don't care if this one works, right? Because we already know it's no. Does this one work? Yes. And this one? Oh, so sad. So we can fill in this one as a no. Sad. And we can fill this one as a no. So sad. Why are we filling it as a no? What do you mean it won't work? Oh, it doesn't meet both of the requirements, right? It doesn't mean both. It meets one, like both. Well, this one works, but this one doesn't. It doesn't matter if one works and one doesn't. It has to meet both requirements, doesn't it? So this one, yes. And this one also? God bless you. Now, rather than making a list of all possible dimensions, because if you think about it, how many possible dimensions are there? Yeah, even more than a lot, right? An infinite amount. They kind of gave us a hint to it as of right here, right? Because we could have 81 and 58, we could have 81 and 57, we could have 81 and 56, and 81 and 55, and 81 and 50. I don't want to keep saying that, right? But not only that, we could have 81 and 58, and 81 and 57.5, and 81 and 57.4, and 81 and 57.3, and 81. And that's just with one decimal place, right? This one can be all the decimal places too, right? So is it possible for us to list all the dimensions? No, no. That's why we have an inequality, right? So instead of listing all the possible dimensions, we can graph them using a system of inequalities. So we need to write those inequalities, all right? So this was the restriction. The rancher can afford up to 300 feet of fencing. You guys told me a minute ago, if it's up to 300, that means it could equal 300. Otherwise, it has to be less than that, right? That's what you told me. I agreed with you because you were right. Okay. And you also told me that perimeter was two of these plus two of these, right? How would we set that up like in a math sentence? What would it look like? Two of these and two of these has to be related to 300 how? Less than. Perfect. To, oops, 300. Now, why do we want it to say graphing from? What are we going to graph it from? Well, it needs to be solved for y, doesn't it? How do we solve this equation for y? Well, I'd subtract 2x from both sides, right? And then what would I need to do? That would give me 2y is less than or equal to negative 2x plus 300. What would I have to do then? Divide everything by 2, right? So that would be y is less than or equal to, God bless you, negative x plus 150. Does that make sense? Okay. The pen must enclose an area of at least 2,600 square feet. What does that inequality look like? How did we find the area? So xy, good. And how did that relate to 2,600? Very good. I'm glad you're here today, Genevieve. How would we solve that for y? Right? Y is going to be greater than or equal to 2,600 over x. Now we have one more restriction that we didn't have to deal with up here because of what they told us in the sentence in the beginning. They said, for purposes here, we're going to let length x be larger, the larger of the two dimensions. So how do I set that up as an inequality? Well, what are the two dimensions? X and y. And what has to be true about them? X has to be bigger, right? So x is greater than. or what? Uh-huh. They can also be equal. Okay. Now, what does that look like if I have y on my left-hand side? Less than or equal to x, right? If x is greater than or equal to y, does it make sense that y would be less than or equal to x? Yes? Okay. So let's graph these three lines over here. Okay. I'm going to graph this first one with navy. Okay. So how do I graph this? It's a line. So I've got a slope and an intercept. What do I do first? Rise 150. And then what? What's my slope? -1. So if I fall one and right one, fall one and right one, fall one, is that the same as falling 10, running right 10? Are you okay if I do that? What kind of a line is this? Solid. How do you know it's a solid line? Yeah, or the equal to, right? Okay. So, oh, that's not long enough. Guys, are you okay with only looking at the first quadrant of the graph? Why don't I have the whole graph up here with 1, 2, 3, 4 quadrants? I don't need it, right? Why don't I need it? X is what? The length, right? The length, and Y is what? Also a distance, right? It's a width. What kind of rectangle are we going to have that has either a negative length or a negative width? Yeah, that's not real, right? So we only need to look at positive values here. Does that make sense? Okay. I know it didn't give you an option. It gave you this graph like this. I wanted to make sure you understood why. Okay. All right. How do we graph this one? It would be a lot easier if I had a table, right? I wish there was a way I knew how to do that. Oh, oh yeah, right. Okay, so in my calculator, I can put in, let's see, what do you want me to put in the calculator? Want me to start a graph? 2600 divided by x? Did it divide or no? Yes, okay, awesome. So if I go to Control T, this is not going to help me a whole lot. It's going to tell me it's 0, it's undefined. That's because I'm dividing by 0. But at 1, it's 2600. So 1 is 20. Oh, I can't even graph that, right? So I need to get somewhere that's less than 150 for my y value so I can even see it on my graph, right? Okay, well, there's 16 or 18. I can finally see it, but let's go to 20. Why am I going to go to 20? Because I can see that on my graph, right? Okay, 18 is kind of hard to see. 20, it says, should be 130. So 20 is 130. Oh, that's so nice. And then let's go find some other nice ones. Do you see any nice ones on yours? 26 is 100. So 26 is about right there-ish. You guys see any other ones? 40 is 65. Anybody see any other ones? 50 is 52. So you see what I'm doing, right? I'm just scrolling on my graph. $65 is what? Okay, 65 is 40. 65 is 40. So I'm just scrolling on my table to try to find numbers that are nice. I could try the other ones. It's not like I don't want to use the other ones. It's just like 126 is a lot easier to try to graph, right? 126-ish right there. I mean, it tells me 104 is 25. That's pretty close to what I already have. So let's try to find one over here. It says 125 is 20.8. So like right there-ish. 130 is 20. That's nice. It goes right there. I don't know if there's any more that are nice. 250. There's not. Okay. So this one's going to be a little bit harder to draw, only because it's not a straight line though, right? But we don't give up when things are hard, do we? How's that? Pretty good? Now, am I taking points off on yours for that and that? No, because it was already a guesstimate to begin with, right? We got close, didn't we? All right. And then the last one, how do I graph the last one? That's a line. What's the y-intercept? 0. Rise 1, run 1. Same thing as before. Is it okay if I rise 10, run 10? Okay. Okay. What's left to do? For a system of inequalities, what do I have to do? Shade, right? I need to shade. Okay. So this line that I just drew right here, it's a less than line. So where am I going to shade for that? Below it. Here, here, here. Okay. So far, my solution is somewhere down here, correct? For the first line we did, it was also less than. So this first line we did is also less than, so it is below. So far my solution is somewhere right there, right? So what's left is this, right? So it's greater than. So do we automatically just show up, or do we think about it? If we think about it, we can't use 0, 0, because that's going to be dividing by 0, right? But if I use 1, 0, so like somewhere right over here, very close to that, if x is 1 and y is 0 greater than or equal to 2,600? No, so it is on this side, isn't it? So where's my solution? Right there, right? Okay. Now, use a calculator to help you sketch the graph of this system of inequalities. Now, let me make sure you understand something real quick, okay? I'm going to go back to the graph, and I'm going to zoom in because you know how my calculator gets when it's like it gets shy or something. It doesn't want you to see it. I'm going to change my window, so I'm going to go Menu, Window, Window Settings. So I need to go from 0 to 150 and from 0 to 150 because that's what my graph that's given shows, right? So right now what I have is that line, right? I need to make sure that you know that we can do something. This is actually greater than or equal, right? So if I hit delete, I can actually, on the equal sign, I can actually choose greater than or equal. Oh, it's mad now. Okay, 2600 divided by x. So it will tell you where to shade, which is all fine and good until you try to go look at the table. Control T. Why is it always when I'm trying to show you something that it's not going to do that it does it? Why? 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 Sometimes when you're in an inequality, it won't show you the table. Okay? Control T. Let's see if it'll do it if I add another one. Tab. escape, tab, tab. Okay. So I want to do y is less than or equal. No. Less than or equal to. Oh, I don't need two of them. Negative x plus 150. Okay, now it's just being a jerk. Now it's just laughing at me. Oh, look, let's see. It won't show me that. It'll show me relation to. No. See, it's not letting me. It's not letting me look at the table. I think because I had it in there as a function to begin with, it's showing in the table. Here, let me try something really quick. Here's a graph. If I delete this and put greater than 2600 divided by x, Control T. There we go. I started with the function, so it's going to show me the table. I went back and changed an inequality. It won't show me the table. That's what I was trying to show you. Okay, so just be careful of that. Otherwise, when we graph, if we will just enter the graphs, we can figure out with our brain where to shade, right? So if I just put in negative x plus 150, and I just put in 2600 divided by x, and I just put in x, and then again I change my window to be from 0 to 150 and 0 to 150, it will show me what it looks like, and I can use my brain to figure out where I should shade. Okay? So it does ask me to do that, by the way. It says use the calculator to help you to sketch the graph of the system of inequalities. I didn't need the calculator's help. I was using the calculator to help check my work. Do you see the difference? Okay. Now, list several other possibilities of dimensions that were not on the list above. Tell me several other possibilities of dimensions, including any vertices or points of intersection. So what do you think? What's a possibility for uh, the lengths of this rectangular pen that they're making? For, I don't know, sheep, cows, goats? It doesn't seem like you would need this kind of a big pen for chickens, but I don't know about chickens very much. Only that you have to hold them upside down when you show them. That's what I know. Okay. Anybody got any? 140. You guys agree with that? 140. I agree with that. Somebody else, give me another one. 70. 70. Ooh, look at that. Why did you choose that one? It's on the border, right? It's on the edge. And because these are both solid lines, you know that works, don't you? You know it works. Okay. What else we have? 80, 50. Does that one work? You guys okay with that one? Yeah. What point is that right there? I did a terrible arrow. I want to know this point right there. That's what I want to know. Can we tell by looking at our graph? We can't really, can we? Okay. I mean, we maybe can probably guess. If you had to guess, what would you guess it was? 75, 75? How could we make sure that that's really where it was? Yeah, calculator, right? Point of intersection. Would you do that really quick and tell me if you agree with the fact that it's 75, 75? Yes? No, I'm not mad. I'm just waiting for everybody to do it. I promise you would know if I was mad. Promise. It is, right? It is 75, 75. Three of you? Three of you did it? Awesome. Four? Okay, awesome. That's a good start. Let's go ahead and find this one as well. Can we assume that that one is 60, 60? Because that's where it looks like it is on our graph. We don't assume, do we? Good. So check it out. Use your calculator. Intersection. I said 60, 60. I meant 50, 50. Sorry about that. Because that's what it looks like, right? 50 and 50. What is it actually? Mm-hmm. It's 51s. Good thing we didn't assume, right? And what's the last one that you think that I want to find? Yep, that one right there. Menu, analyze, intersection. One 30, 20. Tell me two more that are not boring. Not boring. Tell me two more that are not boring. 150. Well, I guess that's kind of. How about this? That's not boring, right? What about this one? 72.5, 61.3. Yeah? So you are doing the other side, okay? You're doing the other side. You're doing macaroni and cheese. I would like to apologize for saying macaroni and cheese when I don't have any to share, because I love macaroni and cheese a lot. Our favorite macaroni and cheese is pizza macaroni and cheese. Have you ever had it? We just make macaroni and cheese like normal, just like regular macaroni and cheese. But then also at the same time, we brown some ground beef, but also warm up some Canadian bacon. And sometimes we put some Italian sausage in there too. And then sometimes we cut up some olives. My husband doesn't like them though, so we don't do that a lot. And then sometimes we brown some onions and some bell pepper, and then we mix it all into the macaroni and cheese. It's like pizza macaroni and cheese. Dang it, now I really want some macaroni and cheese. Okay, any questions about this one? Okay,